Alrighty, section 2.5, inverses of elementary row operation matrices. Okay, so the inverse of EIJ is just EIJ. Now, that makes sense, right? Because remember, EIJ swaps rows I and J. So to get back to the identity, I just need to do it again, okay? And so we can check that, if I take something like E12 in, say, we'll go with 3 by 3 just so we have more than just the okay, so E12 in 3 by 3 is the matrix. So if I just want to swap 1 and 2, right, I swap those two rows in the identity matrix. Gosh. Okay, there we go. And there's E12. And now if I multiply 0, 1, 0, so supposedly this is its own inverse, right? So if I multiply those two together, okay, first row, first column, you dot those two together and you get a 1. First row, second column, dot those two together, I get a 0. First row, third column, I get 0. Second row, first column, I get 0. Second row, second column, I get 1. Second row, third column, I get 0. And then finally, third row, first column, I get 0. Third row, second column, I get 0 again. And then finally, third row, third column, I get 1. And so I do get the identity. There's the inverse. It is its own inverse. Then if we multiply by t, all right, we're just multiplying a row by t. Well, all we have to do there is multiply that same row again, right? So that's EI, by 1 over t. And so they write it as t inverse in the text, okay? So that's EI of 1 over t, multiplicative inverse of t. And again, I'm not going to write down the E2 or what, but here's in 3 by 3 stuff, right? If I have E2 is E2 of 5, right? So that'd be 1, 0, 0, 0, 5, 0, 0, 0, 1. And so E2 of 1/5 would be 0, 1/5, 0, and 0, 0, 1 here. And again, this is pretty quick, right? First row just gives me back the first row of the matrix on the right. Second row, multiplying by the 0, 5, 0, I'll get 0 for the first row. I'll get 1 for the second row. There's my identity making up, and 0 for the third entry in the second row. So first column, second column, third column. And then 0, 0, 1, the last row here dotted with these, I just get the 0, 0, 1 back. Yay! Okay, so that did wonderfully. And then finally, if I want the inverse of, well, let's see. They put parentheses. Well, I can write it like this. Okay, so the inverse of Eij of t, where we added one row to a multiple of another row, and what we do is we simply do that same thing, but subtract that row back out, and let's see that we get an identity here. So again, let's use 5 for t, and we'll use E12 again. And so if I go with E12, remember that it's, well, let's go with E13. So let's go with E13 of 5. Then E13 says I'm going to add row 1 and 5 times row 3 and put that back into row 1. So it's the row 1 that gets the 5 up here, but in column 3. And then 0, 1, 0, 0, 0, 1. And now if we multiply that by 1, 0, negative 5, 0, 1, 0, 0, 0, 1. Well, let's see. So 105 times 100, we get 1, that dot product. And then 105 dotted with 010, so first row, second column, we get a 0. And now first row, third column, we'll get 1 times negative 5, and then we'll add that to 5 times 1, so that becomes 0. Perfect. Then the second row, 0, 1, 0, just gives me the second row back of this matrix. And again, 0, 0, 1. Okay, so there are our matrices and our inverses for those. And so, you know, my row reduction now can be thought of as starting with some matrix A, right? And if I'm attempting to get to reduced row echelon form or something like that, you know, great. But what I can do is a series of these row operations, and so, you know, for instance, I might, you know, start with swapping 2 rows, you know, so maybe I swapped row 1 and 4, and that I multiplied by A, and I get a new result, and then maybe I add row 2 and row 1, but it was maybe negative 2 times row 1, you know, something like that. And you know, and then perhaps after that I did something like row 3 and row 1, and you know, maybe that was a negative 1/2 or something like that. And you see, these are my row operations, but in the end, then I can kind of put those all together into some matrix like L or something like that, right? So this is, whoops, you know, this I could write then as L times A. Okay, so let's kind of see that in action. And so, you know, suppose I have a matrix like, you know, let A equal 0, 1, 2, and then 3, negative 1, 4, and 1, 0, and 6. Okay, so suppose I have a matrix like that. Then if I want to do row reduction on that, probably what I want to do is swap row 1 and row 3. And so I'll start with multiplying my matrix A, 0, 1, 2, 3, negative 1, 4, 1, 0, 6. Okay, I will multiply that by swapping row 1 and row 3, so that's 0, 0, 1, 0, 1, 0, 1, 0, 0. And so when I do that, keep hitting something that makes this reduce. This new matrix that I get is equal to 1, 0, 6, 3, negative 1, 4, and 0, 1, 2. Oops, negative 1, 4. Okay, so then at this point, it looks like what I'd like to do is take row 2 plus negative 3 times row 1 and put that back into row 3, row 2. Row 3, silly me. Okay, so that matrix, we're putting it back in row 2. So we've got 1, 0, 0, and we need column 1 to have a negative 3, 1, 0, and then 0, 0, 1, times our last matrix update, which was 1, 0, 6, 3, negative 1, 4, and 0, 1, 2. And so that is equal to, all right, 1, 0, 0 times, this thing just gives me the top row back, 1, 0, 6. Now, negative 3 times 1, and then plus 1 times 3, I get 0. Negative 3 times 0 plus a negative 1 gives me negative 1. And then negative 3 times 6 is negative 18 plus 4 is negative 14. And then 0, 0, 1, the bottom row, times each column just gives me back the 0, 1, 2. And so that's where I am after 2 of these. And now I actually sort of have a choice. It looks easiest just to add the 2 rows together first to get rid of that 1 on the bottom. So I'll do that. Now you could also change the negative 1 first. I don't, whichever. But I think what I'll do is I will just take, I'll add rows 2 and row 3 and put that back into row 3. Okay, so that is an E, and remember 3 comes first, so E32 of 1. And so E32 of 1, well, so that's 1, 0, 0, 0, 1, 0. Now row 3 is where I change things up, and 0, column 2 gets a 1 and a 1 like that. And multiplying on my matrix, 1, 0, 6, 0, negative 1, negative 14, and 0, 1, 2. Okay, when I multiply those, again, the first 2 rows don't change because I've got the first 2 rows of the identity up there on the left. So I get 1, 0, 6, 0, negative 1, negative 14. And now the bottom, I take 0 plus 0, I get 0. Negative 1 plus 1, I get 0. And negative 14 plus 2, I get negative 12. Okay, and oops, and now, finally, I'll just, I'm just going to stop after, I guess, taking care of the negative 1 and the negative 12. Okay, so I'm going to take minus 1 times row 2 and put that in row 2. Now notice you actually can combine these things. So I'm also going to do negative 1/12 times row 3 and put that in row 3. And I can actually do that as a single matrix because remember on this one, you know, when I do E2 of negative 1, the only thing I change is that 1 in the identity matrix at row 2 and change it to a negative 1. And similarly, the only thing I change here, you know, for E3 of negative 1/12 is that third entry and make that a negative 1/12. So combining those two ideas, I could write this as 0, 1, 0, 0, 0, negative 1, 0, 0, 0, negative 1/12, and times my most recent matrix, 1, 0, 6, 0, negative 1, negative 14, and 0, 0, negative 12. And when I do that, I'll just put it here, 1, 0, 6, negative 1 times the second row, so 0, 1, 14, and then negative 1/12 times third row, and 1. Okay, so now I didn't get rid of the 14 and the 6 yet. I can do that if I wanted to go further. But notice at this point, I have taken all these matrices. So let me kind of go back and so I need to take my, you know, I started with R1, R3. So this was, so I had A, and I multiplied by E1, 3. Then that answer, going back here, right, there was the E1, 3. Then I multiplied by, I guess I didn't write it down here, right, I multiplied by E2, 1 of negative 3. And so, you know, I had this E2, 1 of negative 3. So I multiplied by that. And then I multiplied by E3, 2 of 1. Okay. And now I put these together, but what I, you know, if I write them separately, I multiplied by E, what is it, 2 of negative 1, and E3 of negative 1/12. Okay, so I have this matrix L, you know, so I could call this L times A. And that gave me a new matrix, U. Now, the reason I'm using L is this is lower triangular, we'll see. And I ended up with U, which is upper triangular. And so we can see the upper triangular here, right, is everything above the diagonal is either 0 or non-zero, but could be non-zero. Everything below the diagonal is 0. So this is an upper triangular matrix. Lower triangular is the opposite, and that is that if I multiply by the what am I? Oh, it's the opposite. I lost my train of thought. Derailed. Sorry. Then you'd have the diagonal, and everything below it could be non-zero, but everything above would be 0. So let's check that out. Okay, so I have all these matrices here. 1, 0, 0, 0, 1, 0, 0, 0, negative 1/12. I have the matrix 1, 0, 0, 0, negative 1, 0, 0, 0, 1. Okay, E3, 2 of 1. That was 1, 0, 0, 0, 1, 0, 0, 1, 1. E2, 1 of negative 3. So that's 1, 0, 0, negative 3, 1, 0, and 0, 0, 1. So notice all these matrices I made are lower triangular. And then finally 1, 3, E1, 3. So that is, oh yeah, I did swap that. So that matrix, we may not get lower triangular because of that swap right there. So we'll see that certainly those 4 are lower triangular and should produce a lower triangular. But yeah, I forgot we had to swap 2 rows. So this isn't lower triangular, is it? 0, 0, 1, 0, 1, 0, and 1, 0, 0. So, oops. Okay, so oops. Sorry, forgot about that very first one. So, though, let's multiply these 2 things together. And notice when I multiply these first 2, right, the first row stays the same, the second row stays the same, but the last row gets multiplied by the negative 1/12. And so I have 1, 0, 0, 0, negative 1, 0, 0, 0, negative 1/12. And then that's times 1, 0, 0, 0, 1, 0, 0, 1, 1. So if I didn't have to do any row swaps, I would have all these lower triangular matrices. But as soon as I did that row swap, that messed everything up for a lower triangular matrix. So L, this is a wannabe, right? It wants to be a lower triangular. So reckon a good story with facts. 0, 0, 1, 0, 1, 0, 1, 0, 0. So again, as long as you don't have to do any row interchanges, see, these things are all going to be lower triangular. So now I'll multiply these 2. Top row stays the same. Then I multiply the middle row by negative 1, so 0, negative 1, 0. And multiply the bottom row by negative 1/12. So that's 0, negative 1/12, negative 1/12. 1, 0, 0, negative 3, 1, 0, 0, 0, 1. And times our darn, we call this a pivot matrix or a permutation matrix. It permutes the columns or rows, in this case the rows. And so finally with these 2, and we'll still see lower triangular at that point. Okay, top row doesn't get changed because I've got 1, 0, 0. So this is 1, 0, 0. Middle row just gets multiplied by negative 1, so that's 3, 1, 0. and then I have negative 1/12 times negative 3, which is 1/4. And then negative 1/12 times 1, which is negative 1/12. And negative 1/12 times 1, which is negative 1/12. Times 0, 0, 1, 0, 1, 0, 1, 0, 0. So, yeah, you know, I kind of lied to you about the lower triangular, but there you see it. There's the lower triangular, and then as soon as I throw in that pivot matrix and get that multiplied in there, well, the top row stays the same, and we now are no longer lower triangular, 0, 0, 1. And then I take 3 times the top row plus 1 times the middle row. So the first one is 0, the next one is 1, the next one is 3. And then finally, the negative 1/4, negative 1/12, negative 1/12 times, you know, dotted with each column, I'll get a negative 1/12, a negative 1/12, and a 1/4. And so what you see is this this matrix multiplied on the right of this matrix. It didn't swap the rows, it swapped the columns. It swapped columns 1 and 3. But there we go. This is L. And there we have it. And finding L inverse is pretty simple because, again, you know, all we have to do is do the inverses of all these. So where did I write these all down? Okay. So L was equal to the product of E3 negative 1/12, E2 1. Go back here. E2 negative 1. E3 2 of 1. And hopefully not making you too dizzy there. E2 1 of negative 3. And E1 3, right? We swapped, yep, E1 3. Now, so what that means is the inverse of L is equal to, now when I take inverses, remember it reverses the order. And so this is E1 3 inverse, E2 1 of negative 3 inverse, E3 2 of 1 inverse, E2 of negative 1 inverse, and E3 of negative 1/12 inverse. And so then each of those inverses, well, inverse of swapping rows, it is its own inverse, so that's E1 3. The E2 1 of negative 3, that inverse is just E2 1 of 3, the negative of 3. Same thing with here with E3 2 of 1. Now we've got E3 2 of negative 1. Did I write that right? Yeah, E2, yeah, okay. And then when we multiply through, that inverse again is E2 of, in this case, negative 1, because 1 over negative 1 is negative 1. So that ended up actually being its own inverse. And then finally, E3 of negative 12, okay, the multiplicative inverse of negative 1/12. And so there's L inverse. And I could go through and just multiply those. If I had this in Sage Math, right, those multiplications would be very simple, and I could get that done very easily. Okay, so there is a lot more with these elementary row matrices. And again, sorry I messed up on the lower triangular here. If we hadn't had to swap any rows, we would have had a lower triangular on the left. When we multiplied that by A, we would have gotten that upper triangular matrix U. Okay, and we might see the significance of that at some point. I'm not sure, but there we go.